So we'll make a start. Hello and welcome to all of you who've joined us for this online media briefing. I'm Joe Milton from the Australian Science Media Centre. Now, before we begin, please note that the paper in the New England Journal of Medicine we're talking about today and all the information in this briefing is under a strict global embargo until 7 a.m. AEST, that's Sydney time, on Thursday, 27th of April, tomorrow. So please don't publish or broadcast your stories until then. Now, today's briefing is to announce the results of the BRACE trial, which is a large multi-country study which looked at whether the BCG vaccine, which is normally used to prevent tuberculosis, can protect healthcare workers against COVID-19. Our speaker this morning is Chief Principal Investigator of BRACE, Professor Nigel Curtis. Nigel is the leader of the Infectious Diseases Research Group at the Murdoch Children's Research Institute, and Murdoch Children's led this study, the BRACE study. He's also Professor of Pediatric Infectious Diseases at the University of Melbourne and Head of Infectious Diseases at the Royal Children's Hospital in Melbourne. Now, there'll be an opportunity to ask Nigel questions at the end of his presentation. You can ask questions by typing them into the Q&A box or raise your hand and we'll unmute you. For anybody who's joined us by phone, if you'd like to ask a question, you can raise your hand by pressing *9 on your dial pad and we'll unmute you. So we'll begin now with Nigel's presentation. Handing over to you, Nigel.
Okay, thank you very much, Joe, for that introduction. And thank you, everybody, for joining today and for giving me the opportunity to tell you a bit more about the BRACE trial. But what I would like to emphasize is that although I'm the chief principal investigator and the head of the trial, this has been a very large trial across multiple countries and has involved over 400 researchers worldwide in Australia, in the UK, the Netherlands, and Spain, and in 3 sites across Brazil. And I'd really like to thank all my collaborators and those who've helped with the trial and recognize their contribution. Now, I know that you have all seen the paper that will be published shortly in the New England Journal of Medicine, and you'll have seen the conclusion that in our multi-site, double-blind, randomized controlled trial involving nearly 4,000 healthcare workers in 5 countries, BCG Denmark vaccination did not result in a lower risk of COVID-19 within 6 months than those who received placebo. Now, this, I have to say, is a simple conclusion, but it is somewhat, does really fit with this description of science being the art of systematic oversimplification. And I know that in your profession, journalism is often the art of the incomplete and you get bits and pieces. And so what I hope today to do is to provide you with some more details and background to the trial, because there are some nuances, particularly towards the end of my talk, that are very important to get across, as well as that simple finding. So a bit of a trigger warning, because I'd like to take you back and tell you the story of the BRACE trial. And I'm taking you back to the very beginning of the pandemic. And as you know, the first case of COVID-19 was described at the end of 2019, the first death at the beginning of January. The first confirmed case in Australia was on the 25th of January, our first fatality at the beginning of March. The pandemic was declared in the middle of March by the WHO, and Australia declared a human biosecurity emergency in mid-March. And of course, we were seeing pictures like this of, particularly coming out of China, of very sick patients in intensive care wards. We were seeing hospitals being built rapidly in China, and we saw that healthcare workers were highly vulnerable, and there was quite a high fatality rate amongst healthcare workers at the beginning of the pandemic, and everybody was extremely worried. And of course, it's kind of hard to remember now looking back how we all felt, particularly us healthcare workers in hospitals. We were quite fearful of what was to come. And we were told that it would take a long time for a COVID-19 vaccine to become available. And this graphic nicely shows you from April 2020 that using the usual timeline of trials for a new vaccine, we would expect a vaccine by November 2033. That's not a misprint, that's 33. And so we wondered whether there was anything else we could use as a stopgap before COVID-19 vaccines became available. And one such option was a vaccine that we've had for some time, the TB vaccine. This vaccine, BCG, is given all over the world. And this map shows you the areas of the world where there are still high rates of tuberculosis. And it's given to babies in those parts of the world shortly after birth. And in fact, the majority of babies in the world, 120 million of the 130 million children born each year, receive this vaccine, as I say, as a newborn. And this is a very old vaccine. It's one of the oldest vaccines that we're still using. It was created over 100 years ago by Albert Calmette and Camille Guérin at the Institut Pasteur. And interestingly, if we look back at one of their papers, this one from 1931, they actually reported that the vaccine did work against tuberculosis, but also reduced general mortality. And I'd like to tell you a little bit more about that. We now understand that this vaccine, which is a live weakened version of a bacteria that is a relative of the TB bacteria, so Mycobacterium bovis it's called, this vaccine protects against its target pathogen, which of course is tuberculosis. So this is protection against the bug for which it was designed. But we now also understand that this vaccine has quite profound effects on the immune system, so that it protects against bugs other than tuberculosis. And these are called the non-specific or off-target effects of this vaccine. And these effects mean that you can protect against other infections. And of course, we thought potentially COVID-19. So at the beginning of the pandemic, there was a number of reasons to think that BCG might be able to reduce the impact of this particular virus. And one thing we had begun to understand over the last decade is how BCG affects the immune system. And it's this concept of inducing trained immunity. Now, this is really where BCG can boost the first part of the immune system, what's called the innate immune system, to strengthen that first line of defense that we use before the body creates antibodies and T cells, which we've heard lots about over the last 3 years. But before you get to that part of the immune system, the first line of defense is the innate immune system, and BCG can strengthen that by this concept of trained immunity. And we know from many experiments over more than 50 years that in the laboratory, in animals, you can protect them against multiple different viruses and bacteria. And this has been known for some time. And we also know that it depends which particular viruses and bacteria, and not every BCG can't protect against every different kind of virus. So it's very important to test this. In humans, there's some very important studies from high mortality countries in Africa. In trials in Africa, it's been shown that if babies who do receive BCG have improved survivals compared with babies who do not receive BCG, and that difference in survival is not explained by protection against tuberculosis, but rather by protection against the viruses and bacteria that unfortunately kill babies in these parts of the world early in life. So these studies show that BCG protects particularly young infants against multiple different infections. And this is a very important part of the action of this vaccine. We know from many studies that we can reduce hospitalizations and deaths from pneumonia in other countries. And we also know from studies where we can use a virus as a challenge to the immune system in adult volunteers. We show that we can reduce the viremia, the amount of virus in the blood, using BCG. So there are a number of different kind of studies over the last few decades that suggest that BCG has these multiple actions. Now, this was understood quite early in the pandemic, and lots of people were talking about this, including myself. And after this, there were a plethora of studies published where people looked at the instance of the proportion of people that were vaccinated against BCG in the country and how much COVID they had, in an attempt to work out whether BCG may be protecting against COVID-19, and particularly the fact that early in the pandemic, there was very little COVID-19, for example, in many countries in Africa where there is high rates of BCG use. And these kind of studies, there were literally dozens and dozens of them, including even one published this week, suggesting that previous BCG vaccination might be associated with some kind of protection against COVID-19. But I was at great pains over the last few years to say that these studies are highly flawed in that they really depend on numerous different things. It depends where that country is on the epidemic curve and on their testing policies. and their reporting procedures and how well their healthcare system could cope with the pandemic, and particularly the age distribution in those countries, because we know that COVID is more severe in the elderly. And so these kind of studies are quite dangerous. And really, I agree with this headline that back in, you can see here, back in 2020, we just didn't know whether BCG vaccine could protect against COVID-19. And the way to find out, we know that the top of the tree when it comes to testing these things is a randomized controlled trial. There is no better way to test a potential intervention. And this was very much appreciated by Dr. Tedros, the Director General of the WHO, and he was aware of these studies, and he actually contacted myself here at the MCRI to ask whether we might consider be able to do a trial, because we had already been doing trials of the BCG vaccine in infants in Melbourne, and he was aware of these studies that we had published and that this was our area of expertise. And so together with Tedros, myself and colleagues wrote an article that was published in The Lancet back in April, suggesting that we needed to do trials of BCG vaccine to see if it could protect against COVID-19. But importantly, we made the point that the only way that we should be using BCG to protect against COVID-19 was in the context of a randomized controlled trial. Now, our trial got lots of publicity, lots of headlines talking about the TB vaccine. And unfortunately, because of that, we found that lots of people around the world started to try and obtain the vaccine before we had any results or even had started the trials in a desperate hope of protecting themselves. And you can imagine healthcare workers in many countries without sufficient personal protective equipment really wanted to try anything that might help. But we continued to caution against BCG's use outside of trial. And this led to this warning from WHO that you really should kind of re-highlighting the recommendation to only use BCG for COVID in a trial, because we wanted to make sure that we didn't run out of using of the BCG supply for where we know it works, which is to protect against TB in young children. So we recommended that BCG continue to only be used where there was high rates of TB for that purpose. So to get to the trial, we started our trial in March 2020, and overall we randomized nearly 7,000 healthcare workers across the world, and they were randomized to receive either BCG vaccine or a saline saltwater placebo. And we followed all of our participants for 12 months. Now, every time they became sick with any symptoms that might be suggestive of COVID, which we now understand is almost any symptom, I guess, we asked them to get tested with a swab. And we also asked them to record their symptoms on a custom-built app that we made and distributed to our participants. And we were very, we really went to great efforts to make sure that we captured every episode of COVID by respiratory testing with swabs or with rat testing. And we also did questionnaires every 3 months to capture any information that we might have missed. And the important thing for me to tell you at this point is that the results that we're reporting in the New England Journal of Medicine are those after 6 months of follow-up. And that is our primary outcome. We knew we needed to get an answer as fast as possible. But we did continue collecting data, and we'll be reporting at a later date on the outcomes at 12 months. So we're just looking at 6 months, at the 6-month outcomes. And we published our protocol very early on in the British Medical Journal, which you can find. Now, to cast your mind back, because it's easy to forget, that back in March 2020, we were very fearful. The modeling suggested that we would run out of ventilators, and particularly because we were expecting the wave of COVID to hit Australia at the same time as our usual winter influenza season. And so there was worries that we would run out of intensive care beds and that the health system would be overwhelmed. And so we faced a number of challenges. And the first one is that the modeling showed that the wave of COVID was going to hit Melbourne, where we started our trial, within 3 weeks. And so we had to start our trial very quickly. And starting a trial is it takes a lot of time. Usually it would take 6 to 12 months. We had to assemble a research team, design and write our protocols, go through all of the ethical registration and governance requirements, set up databases to collect information, a website, and as I say, the custom app. We had to have laboratory supplies and training of everybody ready. Importantly, we had to make sure we had enough BCG in the country and enough people who could give it. You have to have specialized training to give this particular vaccine. And we had to train our research nurses to do the training, to do the recruiting. So we we set ourselves the target of starting within 3 weeks from the beginning of March. And indeed, on the 30th of March, we started recruiting in Melbourne. You can see here there was social distancing, but at that time, masks were not a requirement. It's quite strange looking at these photographs now of people without masks. You can see here some of our recruiters giving information to participants, taking blood here in the background, and then vaccinating our participants with either the vaccine or placebo, double blind, so neither the vaccinator nor the nurse knew what they were giving, only the database knew. But the next challenge was, of course, that Australia went into a lockdown and there was no wave in March, April 2020. And that meant that we immediately had to think about expanding to other countries where there was COVID and expand internationally. That required us to translate all our protocols and to train all those overseas. We had lots of problems making sure we were compliant with the European General Data Protection Regulation, a word that shivers up my research team. Make sure we had enough BCG to use all around the world. We wanted to use the same, exactly the same vaccine. And we had to train everybody in all of the 36 sites that we eventually recruited our participants in. You'll be familiar with these pictures showing, this is during 2020 and 2021, in different colors, the waves of COVID going through Australia, very low during that period, Spain, the UK, the Netherlands, and Brazil. And you can see that we started in Australia. We rapidly, or not so rapidly, because it took us 3 months, in fact, to get all those requirements in place. But we then started recruiting in the Netherlands, Spain, the UK, and finally in Brazil, luckily ahead of most of the large waves of COVID in those countries. Now, the third challenge to the trial was that COVID-19 vaccines became available far sooner than any of us expected. And healthcare workers are the very people we were recruiting to our study, were of course the first to receive these vaccines. So as I said, the expectation using a usual timeline for trialing new COVID vaccines would have been 2033. But the target was set back in April 2020 to try and have vaccines ready within 18 months, which would have meant August 2021. But in fact, the first vaccine became available at the end of December 2020, when it was given to Margaret Keenan, the first Pfizer jab in the UK. And it is we've all got used to these vaccines and taken them for granted, but it is really unbelievable, quite remarkable that such effective vaccines became available so rapidly, much earlier than even the wildest expectations. Now, this, of course, was great news overall, but was a big problem for our trial because, of course, it reduced the size and therefore the power of our trial. And that's because, of course, once healthcare workers started to receive their COVID-19 vaccines, we decided to stop recruiting to our trial. And that was before our target, which had been 10,000 participants. It also meant that once our participants had been vaccinated, they were going to have fewer episodes for us to record. And in particular, because the vaccines were so effective against hospitalizations and deaths, we would see very few hospitalizations and deaths in our trial. Nonetheless, our trial was very successful in that we did recruit nearly 4,000 participants in the second stage of the trial, which was during the part where we were in areas where there was COVID-19. As I say, we were in 5 countries and 36 sites. We had very active follow-up. Our participants in Brazil were actually telephoned every week to make sure they hadn't had any symptoms they hadn't told us about. We had very clear outcome measures with extensive testing. So we had robust diagnosis of episodes, so we're fairly sure we didn't miss any. And importantly, we had a very high retention rate of 98 to 99% throughout the trial. And another strength, which I probably won't talk much about today, is that we also collected blood samples from all of our participants every 3 months, so that not only could we see if they had seroconverted to the SARS-CoV-2 virus, but so that we could do some parallel immunological studies to understand COVID better. So this is the headline primary outcome result of our trial, looking at the incidence of symptomatic COVID-19, which showed that in the BCG vaccine group, there was a just over 14% estimated risk over a 6-month period and a 12.3% in the placebo group. And the difference between these two groups of 2.4 percentage points is not statistically significant. And so the conclusion, and this is now taken from the end of the paper in the discussion, that essentially BCG vaccination did not result in a lower risk of COVID-19 within 6 months than placebo. But this is an oversimplification, and I'd like to explain a couple of very important points. So the first thing is these results are only relevant to actually mild or moderate COVID-19. And that's because we simply had too few cases to test protection against hospitalization and death. And of course, that was really what we wanted to look at, because that's the outcome that we're most worried about. And there were only a total of 10 hospitalizations in the whole trial and only 1 death, which is obviously very low and too low to make any and come to any conclusion. And I'd like to explain a little bit about the classification of patients in our trial, because we do talk about severe COVID in the trial, because that's how we defined it in our trial. But it's very important to understand that it was actually not severe COVID as we would now understand it. So to take you back, when you're exposed to the SARS-CoV-2 virus, at the beginning of the trial, not much was known about what happened, other than you might get sick or you might not. So you might be symptomatic and have COVID, or might have an asymptomatic infection. And we knew that some people were getting severe disease, seeing what was happening in other countries, and that many of those people wouldn't reach hospital, but they'd be quite sick at home. But other people would be sick enough to need oxygen or ventilation, and unfortunately, some of those would die from COVID-19. Now, of course, what you might expect is that we were looking to see whether we could reduce all of COVID, all symptomatic COVID and all severe COVID. But in fact, right from the start of the trial, I was using these same triangles. We did make the point that there was another possibility, and that was that we would have no effect on symptomatic COVID-19 or even increased symptomatic COVID-19, because the symptoms of COVID are really reflecting your body's response to the virus. And if BCG boosts your immune response to the virus, it may be that you see more symptoms if you've had BCG, but this might not be a bad thing, because you want to have a good response to the virus to kill it. And if you kill it, you might therefore end up having less severe disease. And we postulated at the start of the trial that we might actually see more symptomatic disease, but we may actually be still able to reduce hospitalizations and deaths. Now, in our trial, we had to use a broader definition of severe COVID-19 than just hospitalizations and deaths. So we knew that, so what we did was we classified the non-hospitalized patients into those, we called those who were non-hospitalized, but who were sick for 3 days or more, 3 consecutive days or more. We called those severe disease. And they included people who were in bed for 3 or more days, but also people who just told us, regardless of quarantine and isolation requirements, they wouldn't have been able to go to work, and that would have impacted the healthcare system, because there was this concept that we may have to get doctors and nurses back to hospital, even if they had COVID, if they could work, because we just would have to use everyone available. So we had these categories which were kind of relevant to the healthcare system, and we called all of this severe COVID. But nobody would call this severe COVID now, because, for example, just being unwell for 3 days and unable to go to work, that's pretty much the COVID that I had, but no one would call that severe COVID. We'd call that mild to moderate. But the trial definition, of course, once it had been made, cannot be changed. We are very strict on protocols in trials. And so it's important to understand that although we would now call severe disease hospitalization or death, but in the trial, it had a very low threshold for that definition and included people who were really not that sick, who had mild to moderate disease. So that if we now move, so when we talk about symptomatic COVID-19 in the trial, where we did not see a difference between the 2 groups, we're talking about the whole of that triangle. But when we talk about severe COVID-19, where we also didn't see a significant difference, you'll see that about half our participants had episodes. These numbers are about half on the previous slide, because we had such a low threshold for defining it as severe. In fact, most of the participants who were categorized as severe COVID were simply those who reported that even if they were had been allowed to go back to work, they would have been just felt too lousy to do so. And when it came to deaths, as I say, we just simply had only 1 death and 9 other hospitalizations, too few to make any comment at all about the effect of BCG on the most severe form of COVID-19. So, and that's the first important point that I'd like to really emphasize that may not come through in the simple, kind of in the abstract of the paper. And the second thing is that in any trial, the results only, of course, are applicable to the population in which you've done the trial. And in our case, of course, that is adult healthcare workers. And it is crucial that it is that we don't take away from the fact that we know from multiple studies and trials that in infants it's a very different story, that BCG is a very effective vaccine against both TB and other infections, and we wouldn't want to detract from the importance of this vaccine in that age group. And finally, these results only refer to this one infection that we looked at, and we are looking at other infections. We recorded all the information of our participants, and we'll have some other exciting results to tell you about soon. We're still analyzing those results, and as soon as they'll be available, we will be releasing those, of course. So it remains only for me to thank those who funded our trial. We had a number of funders, funding bodies, both nationally and internationally, and of course, particularly a major contribution that gave us the ability to expand our trial internationally from the Bill and Melinda Gates Foundation. And I'd obviously like to thank all of those organizations. And I'll end there. Very happy to take questions, and I'm available subsequently either on my email or on Twitter. But I will end there. Thank you very much for your attention.